osmotic pressure. We'll denote this one with I. If at all any semi-permeable membrane is used, the solvent goes out from that membrane and solute particles remains in the solution. That let's see what it means. Semi-permeable membrane means partially allows some certain particles which are small in size. Let's discuss this one with one example. Suppose let's take a container and placed some semi-permeable membrane here, and here pure solvent, or else we can say pure H2O, and here we are taking impure one, that is sea water. Nothing but water plus what it contains, water plus H2O. So water plus NaCl. Salt will be there, and we placed a semi-permeable membrane in between these two. What is the function of the semi-permeable membrane? It allows the particles flow from this side to this side, or else this side to this side, but only it allows smaller particles to go through it. What are small in size? Solvent is particles are small in size. I'm not talking about the quantity. Okay, we are taking the solvent as in high quantity, but I am talking about nature of the solvent. That is the first one. This is the point. We are not at all discussing how much quantity of solvent we are taking. We are considering the nature of the solvent particles which are in small size when compared to solute. What is solute means? We are adding something to the water. So water molecular formula is H2O, simple one. If we add some glucose, then glucose is having molecular formula is high. So quantity is also that, nature of the solute is, we are not considering the solute one. We are considering the nature of the solvent here. As the solvent is less in quantity, solute is less in quantity. Always we'll take solvent is high quantity one. But solute is having big size particles, big size molecules. When compared to solvent, these are having less size molecules. This is the difference between nature and quantity. Even though we are taking the solvent in a larger quantity, the molecules of this solvent are small in size, so easily go through the semi-permeable membrane. So how this liquid flows? Either from this side to this side, or else from this side to this side. But what is the correct one? Always liquid flows through from higher concentration to lower concentration. So higher concentration to lower concentration. So pure one to impure one. But what happening here? Our pure water is converting into impure one. But the purpose is we require some pure water only. We don't require sea water. We don't use that sea water. We need pure water. How we can prevent that one? We'll see that next one in the next topic. But the flow of liquid from higher concentration to lower concentration is nothing but osmosis. Flow of liquid from high concentration to low concentration. That is not osmatic pressure, that is osmosis. So we don't want that flow. But how the water is going from high concentration to low concentration, because we are using some pressure on it. So basing on the but now not exactly we are applying pressure, the molecules are itself applying pressure. So that pressure is nothing but osmotic pressure. The pressure, due to that pressure, pure water is going to impure side. That pressure is nothing but phi, osmotic pressure. That pressure is known as osmotic pressure. But we need to stop that pressure. We need to stop the flow, because we don't want impure water. We want pure water. So what we want? We want a reverse process. Reverse to osmosis. That is nothing but reverse osmosis, or else we'll consider this one as RO. We'll find this RO in all our houses. Means impure water is converting into a pure water form. That is nothing but reverse osmosis. But how this happens? Okay, this is water is flowing from higher concentration to lower concentration due to osmosis pressure phi. But how the reverse osmosis can take place? Simple. If we apply pressure more than this phi, if we apply more pressure, more than osmotic pressure, then reverse osmosis is possible. If we apply pressure greater than pi, then reverse osmotic pressure is, reverse osmosis is possible. Our purpose is that only. Convert impure water to pure water. So that basing on, if we apply pi, then flow from higher concentration to lower concentration happens. If we apply pressure more than pi, then the flow of liquid from lower concentration to higher concentration can happen. So what is the relation here? For gaseous compounds, for gases, what is the relation between pressure, temperature, PV equal to nRT? But this one is for gases. But here what we are taking? We are taking dilute solutions. Solutions. Because water plus NaCl, we are adding some solute here. So solution. Can't we write pi instead of P here? Because the pressure applying here is osmotic pressure, that is pi. So pi V equal to nRT. So pi equal to N by V RT. Moles by volume, that is equal to pi equal to concentration CRT. By this manner, we are going to calculate osmotic pressure, CRT, concentration, gas constant, and temperature. Concentration, gas constant, and temperature. Osmotic pressure pi equal to CRT.